Right. Got it.
All right, so this is going to be the learning target number 1 video. And the learning target video is going to be I can create a table of equivalent ratios, and I'm going to find the missing values. Okay, so this is going to be all involved with the fake ratio, the real ratio. It's going to be all the same thing. The only difference between this is every question that you're going to have on this, you could use a proportion to solve it, but we're going to actually use equivalent ratio tables. You'll see in a minute. And then you'll also be using something called scaling. Head up. Okay, so you'll be using scaling on this. Okay, so let's go ahead and flip to the back or page 2 there. Okay. All right. So once again, there's your target. Remember, as I said, that's the big word here for this chapter. Chapter 4 was basic ratio stuff, understanding ratios, writing ratios in 3 ways, finding basic unit rates, defining unit rate, understanding unit rate. Chapter 4 is more just understanding basic ratio language. So that's why it was relatively a pretty easy chapter, I think, for the majority of you, right? So the chapter 5, we're going to take all those little basics that we learned, and now we're going to apply them even more than we have in the past. So for instance, this first one, it says the quantities in the opening activity can be organized into a table. This table is called a ratio table. Everybody put a box around it. That's really the buzzword here for learning target 1. Because the columns are filled with pairs of numbers that have the same ratio. So right here you can see that the fake ratio that was given here was that there is going to be 1 soda for every 3 juices. Okay, that's the basic fake ratio. Right, everybody? Everybody see how I'm getting that? So that means, isn't that the same ratio as if I said I have 2 sodas for every 6 juices, guys? What am I doing to my number of sodas? I'm multiplying by 2. What am I doing to my number of juices? Multiplying by 2. So do you see how that works? Every one of these ratios, you could really write it like this, with a line as a ratio, with an equal sign, with a line, with an equal sign, with a line. Those are all equivalent ratios. You're doing the same thing to the first ratio, or to the top term in the ratio, as you are to the second term in the ratio. So like here, to go from 1 to 3, we'd be multiplying by 3, right?
Yeah.
So then that would be 3 times 3 would be 9. So it's the same flavor. We're going to do a lot of talking with like recipes. And if you make a recipe and you want to triple the recipe, okay, because you're having more people, doesn't it make sense you'd have to triple every ingredient then?
Yeah.
Yeah, that's how this all works. So it's all about equivalent ratios, and then, like I said, just putting them into the table form. Okay, so let's go down here and look at this first one. I'll get rid of that. Okay, it says to make yellow icing, okay, you're going to mix 6 drops. Notice how I put that little bracket on there. Make sure you guys are doing that as well. You mix 6 drops of yellow food coloring with 1 cup of icing. Guys, what is that right there? What have we been calling that? Yep. We've been calling that the fake ratio. That is something that I do a lot of. That is just the initial ratio. That is what we're basing this on. That's the particular mixture that makes this yellow icing. If you use more drops of yellow food coloring or less icing or more icing, it's not going to look the same, right? So if you want it to look the same and you want to make more of it, more of this yellow icing, then you have to keep the ratio the same. Like double both, or triple both, or multiply both of those numbers by 4. So as you can see, we made a ratio table here. We need to now figure out what the ratio is going to be. So this is what this is going to look like for you guys. So this is my fake ratio. We need to get in the habit of doing our edge pieces. So let's do those now. So this is going to be 6 drops of yellow for every 1 cup of white icing. And that's just, again, the edge pieces are just those things that just tells you what your information is. That's just the information you're using. Okay? So 6 drops of yellow for every 1 cup of icing. So you guys can do that basic math. If you're going to do, if you got 2 cups of white icing, then you would need to use 12 drops of yellow. See how I did that? I multiplied both by 2. So it's all equivalent ratios. It says how much food coloring. Remember, the question is always going to have what I call the real information, or the real ratio. And they're either going to give you an actual piece of real information, and then they're going to ask you for a real piece of information. In this case, they gave us that we have 5 cups of white icing. Do you guys all see that? That is my real information. So really, on yours, guys, this would be blank right here. And you'd have to figure this out. See how we made it into a table? So it's just, and I'll show you a proportion here in a minute, okay? But there's our fake ratio right there, guys, right? And then it gave us that we have 5 cups of white icing. So what are we doing to our number of cups of white icing? Multiplying by 5. So what do we have to do to our drops of yellow? Multiply by 5. So that is where we got 30 there. And that was already done for you. But do you guys see how that works? So I just want you guys to all see that all it is a proportion. That's all it is. We would start with our labels. That would be yellow to cups. Yellow to cups. Our fake ratio is that for every 6 drops of yellow is 1 cup of white icing. Then we would put our real information. We are either going to be given a certain number of drops of yellow or a certain amount of cups of white icing. In this case, we're given this. There's our proportion, just like last chapter. This would technically be a unit rate, right? So we're using the unit rate as the fake ratio there. Okay, so you can see we'd be multiplying by 5, we'd get 30. So doesn't it look just like that, guys? It's just in the table form. Cool? Everybody got that? Okay. All right, let's go down here. Let's look at the next one. Joey Chestnut, if you don't know who Joey Chestnut is, he's like the hot dog eating champ, world record holder. He's been dominating hot dogs and hot dog competitions forever. So in a recent year, Joey Chestnut won a hot dog eating contest by eating nearly 66 hot dogs in 12 minutes. Guys, yes, gross. What is this right here? That is my fake ratio. So that is just going to be what we're going to base everything on. Okay? Now, this is what I want you guys to see. So I want to make sure you write this because I'm going to show you this as a proportion first. We know we're comparing hot dogs. You should be writing this. Yeah, we do. Actually, beautiful. Glad you reminded me. We should do edge pieces. This is going to be 66 hot dogs in 12 minutes. Okay, so there's our 2 edge pieces. Again, I just like to get our thoughts down, what we know down. Okay, so we learned that there would be 6. Well, I always start with labels, so let me keep my labels. So we're talking about hot dogs to minutes. Hot dogs to minutes. We know that the fake ratio always goes on this first one. That's going to be 66 hot dogs in 12 minutes, right? And now let's read through. Now, whenever you see the word if, guys, that is almost always going to have, the real information is going to follow the word if. If he ate this many, how many minutes would it take him? Or if he ate for this amount of minutes, 24 minutes, how many hot dogs would he eat? Those are the kind of questions you're going to get. You're always going to get one of the 2 pieces of information. Everybody got that? So, what do we get? If he ate at a constant rate, what that means is, in a hot dog eating competition, probably the rate in which he ate the hot dogs is probably going to change, right? He might eat 20 in a minute, and then he might slow down a little bit, or he might speed up. You know what I'm saying? Like it's not. There's never going to be a consistent thing with this kind of stuff. Okay? So we're saying if he ate at a constant rate, so he ate, let's say, whatever that is per minute or whatever. We could figure it out, but we're not going to. Determine about average or rounding about how many hot dogs did he eat in every 2 minutes. So we need to figure out 2 minutes. Now, as you can see right here, I'm going to show you this 2 ways. Okay, so just watch. This is the proportion method. You can all write proportion method. Okay, which is not what this target's about, but it's for a future target, so let's just practice. What are we doing to our number of minutes? We are dividing them by 6, right? So what would we do to our number of hot dogs? Divide by 6, and there would be our 11 hot dogs in every 2 minutes, right? Now, for this one, it actually worked perfectly where we could turn 12 into 2, right? But there could be a time where this number might be 5. Can you turn 12 into 5 without dividing by a decimal? No. So we'll get to how we do that here in a minute. But right now, we're going to use something called scaling. Okay? Write that word because we're going to hear it a lot. Scaling. Now, what scaling is, and let me, I'm going to pull up this. I'm going to make this white. I'm going to erase what we know here. I'm going to erase this. I'm going to erase. You can leave yours on there, but I just want to show you. I'm going to erase this, and then I'm going to erase this. Okay. Now, basically, what we're doing here is we are given this table. Okay, and we basically have to do something called scaling. Now, what scaling is? Scaling is picking a number that 12 can become, but that number can also become 2. So really, to relate this back to chapter 1, we either have to find a GCF or an LCM of both numbers. Does that make sense? Does that make sense? You have to find something that 12 can become, so that can either be a factor or a multiple, right? And then you also have to find a multiple or a factor of 2. So what that means is we have to look at this and say we either find the greatest common factor or the LCM. Now, a lot of you that are really good with your multiplication tables can just do this mentally, and you can say, well, this one's pretty easy. I can make it 6, right? 12 can become 6 by dividing by 2, and then 6 can become 2 by dividing by 3. You all see that? So if we did that, what are we doing to our amount of time here? Divided by 2. So what do we have to do to our number of hot dogs? What are we doing to our number of minutes to go from here to here? Divide by 3. What are we doing here then? So let me ask you guys a question. We just used scaling, which I've explained, and we're going to practice more. Okay? We're using scaling. Was scaling necessary here, though? No, it wasn't, because couldn't we go straight from 12 to 2? Yes. Yes, we could. Okay? Let me give you another one. You don't have to write this. I just want you to see this. Let's say that, actually, yeah, you know what? I don't want to do it that way. Let me just back up here and get rid of everything. What's another number that I could have scaled to other than 6? Anybody know what that could be? Morgan? 4. I could have scaled to 4. Absolutely. We could have said, oh, divide by 3, right? Divide by 3 would be 22. And then divide 2. Do we still get 11? Yeah. What else could I have scaled to? Think multiples now. 3, 4. 3 wouldn't work because 3 can't become 2, right? You see how that works? Yeah, you can divide by 4, but what are you doing to go from 3 to 2 then? It has to be a common factor, a common multiple. Yep. We already did that one. That's the one we just did. Okay, so we don't know these. So how about, what if I did 24? Can 12 become 24? Yeah. Sure, we'd be multiplying by 2 there, so we would have to make this multiply by 2 to make it what, 132? Yeah. And then what are we doing to go from 24 to 2? Divide 12. Divide 12. There we get 11 again. Do you guys all understand that? Yeah. We'll practice more. This one you didn't need to scale. Okay? Let's go to the next page. Do you always need to scale? When it's a table, we're going to scale, yes. Okay. All right. Here's the first one here. Cans of corn are on sale for 10 for $4. What is that, everybody? Fake ratio. That's our fake ratio. So let's go ahead and do our edge pieces here. We know we can get 10 cans of corn for $4. There we go. That's just our fake information, our edge pieces, right? All right. So would you agree that this right here, guys, is our real information right there? Yes. That's our real information. Now, here's the problem with the proportion method, guys. Watch. If I did the proportion method, I know I'm comparing corn to money, corn to money. We know our fake ratio is 10 for $4, and the real piece of information that they give us was 15 cans. Is there anything I can multiply by to go from 10 to 15? This is when scaling is absolutely necessary. Do you guys understand that? Right? You see what I mean? So this is when we would use a ratio table. Now later on in the chapter, we're going to learn a different way to do this right here that you guys are going to think is so easy. You're not going to usually scale, but you could even scale within the proportion, but I'm not going to talk about that right now. Right now, we have to figure out, here's our table, we need to scale right here. So that means we either need to do a common factor of 10 and 15, or we need to do a common multiple of 10 and 15. Do you guys all see that? Brian?
Yeah, we could do a common multiple.
Okay, what would it be?
It would be 30.
30 would be perfect, right guys? 30 would be perfect. I'll do that first. Do you agree that 10 can become 30? Yes. Do you agree that 30 can become 15?
Yes.
All right, so let's do it then. What am I doing to go from 10 to 30? I'm multiplying by 3, right? What do I have to do to my number of dollars then? Multiply by 3. That's going to be 12. What am I doing to go from 30 to 15? Dividing by 2. So what do I have to do to my number of dollars? So there we go. We end up getting that it is $6 for 15 cans of corn. Right? Now I'll do another one over top of this one. That one's fine. Okay, but let's do another one now. That one got us the answer. That was beautiful scaling. Now let's figure out what we could scale, what we could do right here. What else could we scale to? We did the common multiple, yep.
5.
How about 5? That's beautiful. What am I doing to go from 10 to 5? I'm dividing by 2. So we got to do that to our number of dollars. Divide by 2. That's going to give us $2 for 5 cans. What are we doing to go from 5 to 15?
Times 3.
Times 3. So what do we got to do to our dollars? Times 3. We end up getting, oops, sorry. We end up getting $6 regardless. Do you guys all understand that? You're always going to get the same answer. Guys, I could use any number I want here. I could use anything. I could use 60. I could go to 60, right? Times 5, and then divide 4. It doesn't matter. Are we all understanding this? Okay. So scaling there. So you can see they did it for you down here. They used the greatest common factor there. But you can use whatever you'd like. You can use a CF or a CM. Just keep that in mind. You can use a CF or a CM. And it's always going to be, you're always going to scale to whatever you know, whatever your real information is. Since we knew the real number of cans of corn was 15, then we have to scale to a certain number of cans of corn. Do we all got that? All right. Let's go on to the next one. Joe mows lawns during his summer vacation to earn money. He took 14 hours last week to mow 8 lawns. What is that, everybody? It's a fake ratio, so let's do our edge pieces here. We know that it's 14 hours for 8 lawns. Fake information, fake ratio, okay? Make sure you're always doing those. It will help you, especially later on in this chapter, okay? At this rate, here's the question. Do you agree that every time you see the question, it's going to be the fake ratio, guys? Or, the real ratio? Okay, so if we were doing a proportion here, everybody look, please. If I were doing a proportion here, I know we'd be comparing hours to lawns, right? And that would be 14 hours to 8 lawns. And then they gave us this piece of real information, so 49 would go there. Can we multiply 14 times something to give us 49?
No.
No, we cannot. So there, once again, we're stuck. This is when we have to use scaling. Everybody got that? We're understanding that. Okay? So, we need to use scaling. So really, once again, I wish this wasn't filled in right now, but I'll just blank it out. You really don't know this, you don't know this, you don't know this. Okay, it's all done for you. This is what you're going to have on the test. You're going to have something that looks just like this. And then you're going to have to figure out what that means. So here, we have to scale right here. So we need to either figure out a CF, a common factor, or a common multiple of 14 and 49. Now, could you go off to the side and do your trees for 14? Do your trees for 49? Could you do it that way? And then do 2 times 7, 7 times 7. You would find that they have a greatest common factor of? Not 49. Remember, we only take 1. So our GCF here, actually our only CF, would be 7. If you wanted to find the LCM, you would do 7 times 2 times 7. That would be 98. But I think you guys would all pretty easily see what would be the best choice to use here. 7. So what are we doing to our number of hours here? Dividing by 2. So what do we have to do to our number of lawns? Divide by 2. That would give us 4. So now we know our new fake ratio is that it takes 7 hours to mow 4 lawns, right? Makes sense? If it takes 7 hours to mow 4 lawns, then yeah, sure. It means that it takes double. If you work for double the time, you can mow double the lawns, right? Now, obviously, there's some things here that really doesn't make any sense. We're assuming that all the lawns are the exact same size and all of that, right? But you get the point. So now, what are we doing to our number of hours now? Times 7. What do we have to do to our number of lawns? So there's where we learn that it's going to be 28 lawns, right? And there we go. Everybody understanding scaling pretty well? It's not that hard. Just kind of weird. Okay, but does everybody understand why we have to scale? Does everybody get that? Because there's no way to go from 14 to 49. It's not like one that's like this, where you say, oh, three hours to mow 2 lawns, and then I told you, yeah, well, what if I work for 12 hours? That one, can you go straight from 3 to 12?
Yeah.
So that's why. But if this number was 8, or let's say 22, then you can't do that. You can't go straight from 3 to 22. All right, so let's go on to the next page. Okay, here's one that I'm going to get you guys started here, and then you're gonna do it. So everybody watch here. On her vacation, Leah exchanged 50 American and received 60 Canadian. Guys, is that our fake ratio?
Yes.
Should we all do edge pieces then? Let's all do that then. That means $50 American for $60 Canadian, because you gotta, their money system's different than our money system, right? So use a ratio table to find out how many Canadian dollars she would receive for 20 American. So that's our real information. So we're going to put our fake ratio right here. So that would mean 50 American dollars for every 60 Canadian dollars, right? Right? Now we're going to skip this column here. Okay, so here we're going to leave this one blank, right, guys? That's going to be what I call the scaling. So that's where we're going to scale, right? That's why we have that. Hold on. We're going to scale in this column right here. Our real information always goes in the final one. So what did they give us? Did they give us a certain amount of American dollars or a certain number of Canadian dollars? American, right? So we're going to put that there. Now, before you guys start this, is there anything I can do to go from 50 to 20? Is there any division? No, this is where scaling would be necessary. So I want you to pause and I want you to try this. Okay, so let's do this now. Okay, so again, we have to understand this is where we're scaling right here. Okay, this is what we've got to turn. We've got to basically pick a certain amount of American dollars that 50 can become, but then that same number can also become 20. So that's the very definition of what a common multiple is, or a common factor. And again, that can be the LCM and the GCF, but it doesn't have to be. It can just be a common factor or a common multiple. Okay, so if you went over and did your trees, if we did the trees for 50 and 60, you'd end up getting 2 times
2 times 5
20. Oops, I messed that up. It should be a 3. Okay, so 2 times 3 times 5, right? That would be 60. And then for 50 would be 2 times 5 times 5. So if you did the GCF, you would realize, oh, well, 2 would be what would be the GCF here, guys? The GCF would be 10. And if you did the LCM here, it would be 100. Okay? So either way, now there's other numbers you could use. We could use 2, we could use 5, right? Those would all be CFs, right? Be careful, guys. CFs could be 2, 5, or 10. You could use any one of those. Common multiples could be, it could be 100, 200, 300. You could go any multiple of 100. You guys all understand that? All good? Makes sense, because 50, 100, 150. Anything that's 50 is never going to have a factor of 20, right? So you could do any of these. I don't care what you did. That's kind of the cool part about this, is there's not like a set way you have to do it. But so I'll do it both ways. We'll just go ahead and use. How many of you did anybody use 2 here? No, we can't use 2. What am I talking about? You can't use 2. Sorry. Yeah, you can. Yes, you can. Jeez. Yes, you can. Okay. It would be 25. You could. Did anybody use 2? Did anybody use 5? Did anybody use 10? 10 would be the one. Did anybody use 100? All right, that's okay. I'm going to go ahead and use 10, because that's the easiest one to use. What are we doing to our 50 American dollars? We're dividing it by 5, so then we need to divide this by 5. 60 divided by 5 would give us 12. There's our conversion. So we know that for every 10 American dollars, there's going to be 12 Canadian dollars. Now, we're just doubling the American dollars, so we just got to double the Canadian dollars to get 24. Now I'll do it over here, 50, 60, and then put 20 there. Now we'll use the LCM over here, which would be 100. What did I do to my number of American dollars? So what do I got to do to my number of Canadian dollars? And then what am I doing now? 5. Divide 5 here. What do you get? You get the same exact thing. It doesn't matter. Are we all getting this, understanding this? Scaling. GCF, LCM. Okay? That's why LCM and GCF is chapter 1. We use it a lot throughout the year. Okay? Oops. Let me get rid of that. Get rid of that. Okay? Let me go down here. Here's what the definition of a proportion. We need to start knowing that definition. A proportion is a number, sentence, or equation stating that two ratios are equivalent. Let's just write this one, though, for a definition. Two, you might want to write this for the test because it will be on there. Equivalent ratios. I'm good with that. Two equivalent ratios. That is the exact definition for proportion that you'll need to know for the summative and the formative. It'll be on there. It'll be on the test, I promise you. Okay? This next one here. What is this right here, guys?
Fake ratio.
That's your fake ratio, that for every 25 centimeters is 10 inches. That's the fake ratio. That's what we're basing this on. We want to know what this child's height is in inches if they're 105 centimeters. So where are we going to scale? Are we going to scale here? Are we going to scale in there? No, because we don't know this, right? You have to scale where you know the two numbers. So we're going to scale right there. So again, we can either use the GCF or the LCM. Does anybody know what the GCF of those two numbers are? It's pretty kind of an easy one to see. Or just at least a CF. 5. They both end in 5, so that's an easy one to go to. What are we doing to our number of centimeters? Dividing by 5. So what do we got to do here? Divide by 5. There's 2. What are we doing here? Times 21, right? Right?
Yeah.
And then we got to do times 21 here. We end up getting 42 centimeters. Okay, if we were to use the LCM, that would have been a pretty big number. It's better to use the common factor usually. Okay, and here we go. Here's a little ratio table here that like completing the table. A manufacturer's instructions states that 2 cups of cleaning agent should be diluted with 7 cups of water. So should we do edge pieces? You're darn right we should. So this is going to be 2 cups of, maybe you put CA for cleaning agent, and then 7 cups of water. Or you could put C of W, or however you do it, just as long as you know what the difference is. Okay? So we can see right there is our fake ratio, right, everybody?
Yeah.
Okay? Now this one, there really isn't, the scaling's kind of done for us, right? What are we doing to our number of amounts of cleaning agent?
Times by 4.
Times 4, so what do we have to do to our number of cups of water?
4.
So that's going to be 28, right?
Yeah.
Okay. Now, is there anything I can do to go from 28 to 35?
Add 7.
You can never add or subtract. Let's all write that. You can never add or subtract to find to find equivalent ratios. Just like fractions, guys. I can't say that 1/3 is equivalent to 2/4, can I? Oh, I added 1 and added 1. Can you do that? Hello? No, you can't do that. Wrong. Okay? So now we've got to figure out what the heck we're doing. So what would we scale to? If we were right here, what could we scale to get from 8 to 12?
Divide by 2.
Divide 2 to give us,
It's 5.
what is it?
Times 5.
Times 5 would be, no, wait, you want to make this 40?
Students with the following 7th grade students report today each 40.
Exactly. The issue with this one really here, guys, is this one you'd have to use even more clues because it's like you're looking here, well, there's nothing you can do. And you can't really tell what you're going to scale to. But what can you do? Look at this. Let's just bypass it. What are we doing to go from 7 to 35?
Times 5.
Times 5. So can't you just do that here?
Yeah.
See how we just skipped the scaling there and we end up getting 10? Now we can look and say, okay, well, what about going from, I'll do a different color here. We'll do black. Can I go from 2 to 12 on this one?
Yeah.
Times 6. So what do I got to do to 7? So that's going to be 42. Okay. Now we'll look here and we'll say, okay, I need to figure out something that'll get to 63. Will 42 go to 63? Will 35? Will 28? Will 7?
Yes. Times
Yeah, times 9. So what do we have to do to 2?
Times 9.
Times 9. So that one's really not scaling. That one's really not scaling. That one's just using your clues there. Okay? But either way, we were able to complete that ratio table with all the clues we have using our fake ratio. Everybody got that?
Yeah.
Okay? We go here. All right, and that's going to be it.